Okay, everyone, we're going to go over conditional statements again. I know a bunch of you have sent me emails that you're still a little bit confused. So I just want to go over and make sure that everybody understands what we're working with, how to do them. Hoping I can give you a little bit more, a little bit better explanation of what we're looking to do as we go through it. And then there'll be a bunch of questions you'll have to do at the end of the video as kind of homework thing, just to reinforce and make sure we're able to write all the statements. That'll be your homework for the weekend. So let's get going. Conditional statements. What's a conditional statement? Again, a conditional statement, it's a logical statement that takes on the form if-then. You've heard them before, you've seen them before. There's if and some sort of hypothesis. If this happens, then that's going to happen. That part is the conclusion. So as kind of a jokey example, if the class is confused about conditional statements, then the teacher will create a second lesson. Exactly what we're doing. It's a true statement. Just trying to get people through and understand what's going on. So in our example here, the hypothesis, the term after, or the phrases after if, is the class is confused about conditional statements. The hypothesis doesn't include the if, it's just the words after the if before the comma. The conclusion is all the words after then before the period. So our conclusion then is the teacher will create a second lesson. Hope that makes sense. We'll kind of go through. This next slide has some examples. We're going to go through them. What I've done is I've kept the same 3 example conditional statements to form all of the different forms of our conditionals. So what we're looking today right now is all we're trying to do right now is pull out the hypothesis and the conclusion for each one of these statements, write it down next to the P and the Q, put it down in your notes, and then we'll move on to the next thing. Okay, so our answers. If it rains today, then I will take my raincoat. The hypothesis is it rains today. The conclusion is, then I will take my raincoat. Again, we just leave in everything but the if and the then for our P and our Q letters. If a number is divisible by 4, if a number is divisible by 4, that is our hypothesis. The conclusion is it is also divisible by 2. And then if a triangle has 3 equal sides, it also has 3 equal angles. A triangle has 3 equal sides is the hypothesis. It also has 3 equal angles is the conclusion. Remember, as we're looking at our conditional statements, they may or may not be true. We have to look at each statement individually and determine, find a counterexample. If we can find a counterexample, we just need to find one that proves the whole statement false. That's all you need to do. You're just going to kind of think and say, is there any point ever that this statement is not true or could not be true? Look at what it's trying to tell you. If you find one, the whole thing's true. Okay, now the converse. The converse of the conditional statement is just formed by flipping the hypothesis and the conclusion, flipping spaces for those. So we have this like funny P and Q representation. So if P, then Q is our conditional. The hypothesis is P, the conclusion is Q. The conditional statement then is if Q, then P. You just move them to the other spot. So our examples again, our example before we move on. If my car has exactly 3 tires, then it is missing a tire. Our hypothesis is my car has exactly 3 tires. The conclusion is it's missing a tire. Our converse is going to be if my car is missing a tire, then it has exactly 3 tires. Again, this is math. We're not really worried about the semantics of the English statement, whether it's right or wrong grammatically. We're just trying to convert a statement into the converse, they call it, just by flipping the words. You're going to end up with some statements that just don't make sense at all. Don't worry about it. We just have to write the converse statement of our original conditional by flipping the hypothesis and the conclusion. Again, like I said, we're using the same 3 statements. So we have our statements again. If it rains today, I'll take my raincoat. If a number is divisible by 4, then it is also divisible by 2. And if a triangle has 3 equal sides, then it also has 3 equal angles. I want you to take a minute and write the converses of those 3 statements. Okay, now that you've done that, we're going to show you the answers. If it rains today, then I will take my raincoat becomes if I take my raincoat, then it will rain today. If a number is divisible by 4, then it's also divisible by 2. Becomes if a number is divisible by 2, then it is also divisible by 4. And the last one becomes if a triangle has 3 equal angles, then it also has 3 equal sides. Does that make sense? Is it kind of being clearer now? I hope it is. Again, we'll still work on it. We'll kind of pop these in here and there on like warm-up exercises or something, just to kind of keep it fresh and make sure we understand it for our geometry class. The only other time you're ever going to need this again is for the MCAS is next year. After that, nobody ever talks about contrapositives and stuff like that. So you just need it for geometry. Okay, again, converse statement. The conditional statement, the converse of a conditional statement may or may not be true. You have to look at them all individually. Is it true? Is it not true? Is there a counterexample that proves it false? If you find it, it's false, then the converse is false for everything. The inverse. The inverse is just formed by negating our original conditional statement. So you negate the hypothesis and the conclusion of the original statement and just rewrite it. All we're doing, if P then Q becomes if not P then not Q. That's how you negate a statement. You negate statements by just plugging in a not somewhere in the sentence to make it negative. It's as easy as that. Nothing else to do, nothing else to think about, just plug not in. So, statement, the sky is blue. Everybody understands the sky is blue. To negate that, the sky is not blue. That's all you need to do in the context of what we're trying to do in this logic stuff, is you just say the sky is not blue. Hope that makes sense. Here's another example. If my car has exactly 3 tires, then it is missing a tire. We're negating both statements. All we're doing is plugging a not in. If my car does not have exactly 3 tires, then it is not missing a tire. Sentence doesn't make sense at all. Grammatically, English-wise, it just doesn't make sense, but that's okay. We're working on math. We're just trying to negate our original conditional statement. Again, your turn. Same 3 sentences. Negate the conditional statement and write our inverse by negating the conditional. That's all you're doing. We're writing the inverse. Okay, now that we've done that, let's go over the answers. If it's not raining today, then I will not take my raincoat. Sometimes the sentences make sense. If a number is not divisible by 4, then it is also not divisible by 2. Seems reasonable. Last one, if a triangle does not have 3 equal sides, it also does not have 3 equal angles. All we did is plug not in. You might have to change a word here and there just to kind of make it make sense, because you're not going to say if a triangle has not 3 equal sides. You don't want to sound like Yoda, but that's what you're trying to do. Okay, again, truth statements. We have to look at them individually. Are they true or are they not true? One counterexample makes it false. That's all you need is just one counterexample. That's the inverse. I'm hoping this is making sense. Like I say, I think it should be getting clear once you kind of see it 2 or 3 times. We'll do some more problems after this. You'll be able to kind of get through it. Everything will be good. But the contrapositive, it's the most confusing one. I understand it is. I'm going to try to give you 2 ways to do it now. The first way is the original the mathematical way. It's formed by negating both the hypothesis and the conclusion of the original conditional statement and then switching their locations. So we go to if P then Q becomes if not P then not Q. That is the basic, that's the way a lot of the books describe it. What I'm going to start explaining in the next one is the contrapositive is basically the negation of our converse statement. If you break the first part of it down, the first way to do it down is we're negating both the hypothesis and the conclusion and then switching them. So switching the hypothesis and the conclusion is the converse. So all we're doing is negating the converse statement. Whatever the converse statement looks like, just plug the nots in and you'll get your statement. So it becomes if Q then P equals or becomes if not Q then not P. So we get the same answer both ways. Negating the converse might be a little easier way for you to think about it rather than looking at a conditional statement and saying, okay, now how do I get to the contrapositive? Go to the converse first, then it's just plugging in 2 more words. Again, same 3 sentences, same 3 statements. I want you to come up with the contrapositives for these 3 statements. Okay, if it rains today, then I will take my raincoat. Becomes, if I do not take my raincoat, then it will not rain today. If a number is divisible by 4, then it is also divisible by 2, becomes If a number is not divisible by 2, then it is not divisible by 4. And the third one, if a triangle does not have 3 equal sides, it also does not have 3 equal, if a triangle does not have 3 equal angles, then it does not have 3 equal sides. Hope that makes sense. They say, if we kind of go back and look back at your notes, what the converse statements look like, we just plug the not in. So that's all we're doing to the converse. We talked about the truth statements and the truth values and finding out if things are true. There are relationships between these statements. If the original conditional statement is true, then your contrapositive is going to be true as well. It's just the way math works. The way these work is if the original statement's true, the contrapositive is true. If the original statement's false, the contrapositive is false. You don't have to think about it. Once you see one, you just know right through what it's going to be. If the converse is true, similarly, then the inverse is going to be true. If the converse is false, the inverse is going to be false. So everything kind of hinges on the conditional statement and the converse. If they're both true, then everything's going to be true. If the original statement's true and the converse is false, then the contrapositive will be true and the inverse will be false, and then it's kind of a mixed bag. If we have a true conditional statement and a true converse, then we're able to write what they call the biconditional statement. The biconditional, like I say, is a special type of conditional statement that can be formed when both the conditional and the converse statements are true. Here's our example. If a triangle has 3 equal sides, then it is also 3 equal angles. That's our conditional statement. If a triangle has 3 equal sides, okay, it has 3 equal angles. So think of it, 3 equal sides, it's an equilateral triangle. That's true. It's always going to be true. There's nothing we can do about it. So that's our true statement. Our converse is flipping it. If a triangle has 3 equal angles, then it also has 3 equal sides. Again, equilateral triangle, 3 equal angles. The only way to have 3 equal angles, they're all 60 degrees. That's our equilateral triangle. This statement is true. So because of that, now we can write our biconditional. We have our true statement conditional, our true statement for the converse. So our biconditional statement becomes a triangle has 3 equal angles if and only if it has 3 equal sides. So the conditional statement combines everything with that if and only if. That's the most important part of the biconditional. Once you see that, you know I got 2 converse statements that are true. I got converse true, conditional true, everything else worked from that. So all the statements we could write from that would end up being true. So that's why the biconditional is special. I hope that makes sense. I hope that helped you understand it. Like I say, on Google Classroom, there are going to be some problems to do. They're in your book. They're in your textbook for those who have it. You all should have a textbook. So that's what we're going to be working out of. And enjoy your weekend.